Alright, today we're going to look at something called U-Substitution. Okay? It's a method that is used on some problems that you can't just integrate normally like we've been integrating recently. Okay? And what we want to do is we want to try to fix the problem so that it looks like a simple problem to integrate. So for example, this one, we have the integral of sine of 3x, right? What's making it be a problem? What's making it not be something easy to integrate? The fact that it has a 3 there, right? If it was just the integral of sine of x, then we wouldn't have a problem, right? What's the integral of that? Negative cosine of x plus what? C. So who's my plus C reminder here? Ale? Alright, so don't forget Ale, because today we're not doing definite integrals, so all my answers better have plus C, or else we don't get credit. Okay? No C, no credit. Got it? So we gotta try to fix it so that this right here is not a 3x, but just one single variable, so that I can integrate it like normally. Okay? And that's where we do something called U-substitution. We're going to replace that 3x with the letter U. Okay? You understand? What you want to do is you want to focus on that argument. And we're going to let U be that inner function 3x. Now what's the problem? Let's say I do that. What do I end up with now after I replace 3x with U? The integral of sine of U times what? dx. Uh-oh. What's the problem here? We got U here, but I got dx there, so they don't match. Okay, so I can't integrate when something happens like that. I need to have what there instead of dx? du. Oh my god. So how could I find du? If I know u. Find the derivative of it. Very good. Okay? So find du. So what would the derivative of this be? With respect to x. What's the derivative of u with respect to x? du over dx is equal to, what's the derivative of 3x? 3. Okay? Now notice it says solve the equation for dx. Make it be dx equals, that way I can replace this guy with something that has du in it. Right? So we're going to treat these as two different things. We'll multiply by dx, and then we'll divide by 3, right? So we'll get 1/3 du is equal to dx. So now can I replace this dx with what I know it is?
Yeah.
And can I replace that 3x with u?
Yeah.
And will it work out nice and pretty? Let's see. We're going to get the integral of sine of, what's 3x?
Yeah.
u. What's dx going to be? 1/3 du. Oh, cool. So now I have everything in terms of u. I'm good to go. Now I don't like that 1/3 there, so what could I do with that 1/3 since it's a constant? Take it out, right? So we could say 1/3 the integral of sine of u du. And now it becomes that nice pretty problem that we used to be able to integrate, right? So what's the integral of sine of u? Negative cosine, right? So we would end up with negative 1/3 cosine of u plus what? Plus c. What do you think the final step is here?
Yeah.
Replace that u with that x. So we get negative 1/3
Yeah.
cosine of what? Cosine of 3x plus c. Yes.
Yeah.
How'd it go?
Actually, it was really well.
Awesome.
Yeah.
Good luck. Good?
Is this from homework, everything?
Yes.
Yes? Okay.
Watch the video, okay?
I said, he's playing cricket.
Are we okay? Did I use some of you? I lost you on getting the derivative? That was like getting the derivative implicitly with respect to x. Derivative of u is 1, but if I'm getting it with respect to x, the variables don't match, so I gotta put du dx.
So at the end we just change u to 3x?
Yeah, at the very end, you just replace that u with what it was, 3x, after you did the integral. You're changing it to u so it becomes like something like a single letter, right? And then you can integrate it easily, and then you just replace it at the end. Cool? The second one looks more challenging? Yeah, it's easy. The hard part is figuring out what you want u to be, okay? Now, for the most part, u is always going to be something that's in like a parentheses, or in a square root, or sometimes in the denominator. Okay? So let's write a note for that. U is often, okay, not always, in parentheses, square root, or in the denominator. Now, those are not always the cases, okay? I'm just saying often, for the most part. There's going to be some examples later on where that doesn't happen here. And you're going to have to think about the problem before you decide what you want u to be. Okay? And you have to remember that once you get u, you're getting the derivative of u. So you got to think of that and see if you pick the right u, because it's going to give you the right derivative to get rid of something that you have in your problem. Like here, we didn't have to get rid of anything, right? Everything just replaced itself. But we had to add a 1/3 to it. Okay? This problem, we're going to have to get rid of something, and you're going to see it. Okay? So what do you want u to be here?
2x.
2x to the third. Okay, so let's say that this guy right here is going to be u. And I like to underline the things that I'm going to replace. Okay? But I also need to replace what? Dx, because if I make that a u, that has to be du, right? We learned that right now in the beginning. Alright, so get the derivative of this. What would we end up with? Du dx equals
6x squared.
6x squared. We're going to have to move that dx over there. So maybe in the next example we can just write the derivative and then put dx already over here. Would you be okay with me doing that? You understand that it's du over dx, but we're going to move that dx over there every single time? So can we just put it over there so we don't have to show that step? Alright. So then we divide by 6x squared. 1 over 6x squared du is equal to dx. So let's replace everything with what we got. So we're going to have the integral. Are we replacing x squared? No. We got secant squared. We're replacing this with u, and we're replacing dx with
1 over
1 over 6x squared times. Does something cancel out? Because I still have x's in this problem.
Yes.
I don't want to have x's. So those x squareds go away?
Yes.
Alright, so now we're good. Everything's with u, so we're happy.
And you can move the 1/6 out.
Move the 1/6 out. So we got 1/6 times the integral of secant squared u du. Okay, now we have to remember the antiderivative of secant squared. We can't remember that, we change the question and we say, whose derivative is secant squared? That's an easier one to answer, right? Tangent, right? The derivative of tangent is secant squared.
Yes.
So that means that the antiderivative of this is tangent. So we get 1 over 6 tangent u plus what? Plus c. What's the last thing we gotta do? Replace that u with what?
2x.
2x.
Is that what the song was? Freaking you.
Was that the song what it was about?
Capitalize you and all of them?
Yeah, you like that? The u song?
We should play it again tomorrow.
Yeah. So far so good? Ready for the assignment?
That's it, right?
That's it? I don't know, some people just need one example and they're good to go.
No, but like that's it, like
People learn this in text prep or something, or
that's all we need to learn that.
that's it, no, that's not always.
Well, like just for this, like,
There's always more.
yeah.
Maybe we should do some more examples, just to be safe.
I agree.
Practice being able to figure out what U should be.
Practice makes progress.
So look at this one, okay? You need to be able to see a problem and know that you can't just integrate it like normally. And know that, oh my God, I gotta do U-substitution here, right? So like, if you came across this problem, how would you know that you had to do U-substitution? Kinda looks like I would have to do the chain rule if I got the derivative of it, right? Okay, that's kinda how you know. That's not always gonna be like that, right? Can I integrate this like normally, where I just add 1 and divide by the power?
No.
No, because I have x times something, right? If I would actually expand it and multiply that 15 times itself, right? And then multiply that times x, then I could do just by adding 1 and dividing by the power. But that's gonna take too long. I mean, unless you wanna do it like that. Wanna do it? Come on, it looks like fun. X squared plus 1 times x squared plus 1 times x squared plus 1. Come on! 15 times. No?
So it's been like,
Well, then I guess we better learn U substitution.
no. Yes.
So what do you think U should be here?
Because
That x squared plus 1, right? It was in those parentheses. Okay. So we're replacing this guy, that's good. But we still need to replace this guy. So what would be du? 2x? Can I put the dx right there already? You understand what I meant by that? Divide by 2x, so we get 1 over 2x du is equal to dx. So let's replace what we know and see if it works out. We don't know x, that stays there. We're going to put u to the 15th power, and we're going to put 1 over 2x du in place of dx.
the X is
The x is going? Perfect. The problem fixed itself. Sometimes the problem isn't going to fix itself. Then we got to do something else to fix that. Okay, because we can't have x's there. We've got to have everything in terms of u. Okay, so we'll talk about that in a little bit. Those are problems where you need to change the variables in order to work it out. Alright, so we're ready to go. 1/2 times the integral of u to the 15th du. Oh my God, that became one of those super easy baby problems. We were actually going to multiply it all out. That was crazy. Okay, so add 1 to the power and divide by the new power. What do we get?
You go 16 over 16.
1/2 times 1 over 16 u to the 16th plus c. So what does that give us? 1 over 32. I'm going to replace that u already. X squared plus 1 to the 16th power plus c.
What do you see?
Okay, now some of these problems you're going to notice later follow a particular pattern, right? And instead of us having to go through the whole U-substitution thing, okay, once we're able to recognize those problems that follow this particular pattern, we can go straight to the integral right away. Okay, but it's not until we learn to recognize that pattern that you'll be able to apply it. I didn't want to start off teaching to you like that. I wanted you to actually learn the whole process, okay? So after we do it the long way for like 2 days, then I'll show you those patterns,
Why are you speaking?
or those problems that follow those patterns, to save time. But worst case scenario, you can always resort to this. Okay? Try number 4. What do you think u is going to be here? 5 minus x to the 4th. Okay, get the derivative. du equals negative 4x to the 3rd dx. Divide So we get 1 over negative 4x cubed du is equal to dx. We're replacing this guy and we're replacing this guy. Hopefully that x to the third goes away. Is it gonna go away?
Yeah.
Yeah, because we're gonna have this x to the third down here. So let's do it. X to the third, and I'm gonna put u to the half. Is that okay? Because we're gonna need it right now. Times 1 over negative 4 x to the third du. The x to the thirds go away? Yay! Take out the negative 1/4, integral u to the half du. Oh my god, such an easy problem now compared to what it was at the beginning. So let's go, integrate it. Add 1. 3 over 2 times 2 over 3 plus c. So let's multiply times that 4. We would get 2 over 12, right? Which reduces to negative 1 over 6. I'm going to replace that u already with 5 minus x to the 4th. All of that to the 3 over 2 plus that c. Okay?